In order to understand logarithms, you really have to think very carefully about these inverse functions, or ways that we undo something that's happening to our variable x. So I've written out some of the examples. We saw them all on that worksheet we did in class, where you can see what's happening to x. So the first example, x plus 2. So 2 is being added to x. And we know that if we want to undo that, right, the inverse operation, or the opposite operation, is to subtract 2. In the second example, we can see 2x, the operation that's happening there is multiplication, and 2 is being multiplied to x. So if we want to undo that, we can just divide by 2, right? That will cancel out and leave us with just x again. In the next one, we have x squared. So what's happening to x is that it is being squared, it's being multiplied by itself. And we learned last chapter that we can undo that by using a square root. Now, all the things that we're doing here, you can't just see something and be like, oh, I don't like it. This is what students will do sometimes in classes. They'll see the square root of like 2x, and they'll be like, oh, well, I don't like the fact that the square root is there, so I'm just gonna go ahead and square it to get rid of it. And that's not allowed. What I'm talking about here, this undoing, we're only gonna do when we have an equation, when we have another side of this that we can go ahead and do the same operation to. So as long as I can do the same thing to both sides, that is okay. Be careful again with the square root. We actually talked about that in class. That one has a positive or a negative because it's not a one-to-one function. So this would actually be plus or minus. But the same idea of, okay, I can do the same thing to both sides as long as I'm in an equation. Now the last example here shows us why we have this issue, why we need logarithms in the first place. The last example, x is actually the operation, right? X is now the power, and we don't have any way to get this down. So if we had something like this set up, we might have some ideas, right? We know that 2 squared is equal to 4, and 2 cubed is equal to 8. So whatever the heck this x is, it's probably got to be like close to 2, but a little bit more than it. But we need an actual mathematical operation to figure out what that exact value is. So this is where our logarithms come in. So it turns out that if we do a log base 2 to both sides, that will actually cancel this out. So let's just really talk quickly about the different ways we can solve these equations and what our log looks like. So if we have log base 2 of x, this we read, like I just said, as log base 2 of x. The way we read this is important, and you can say logarithm too. And the way we write this is important as well. We want to make sure our base is down as a subscript is what we call that. So it's a slightly below and slightly smaller. Everything else is on the same line. This is very similar to our square root in some ways, or let's just look at a different radical. So if we look at like the cube root of x, here we have our little index, which tells us what power we would need to have inside there. Same sort of idea that this 2 and the base here and the index here, this is our base, kind of have similarities. And then why I really wanted to draw this is because the inside of our square root, you have to think of whatever comes after the log, which we call our argument. You have to think of it kind of like we had a radicand in our previous radical section, because nothing can touch that. If you have something that looks like this, if you have log base 3 of 4 divided by 2, you cannot divide these together. You cannot do any operations on that, because that is what we are taking the log of. And the first thing we have to do is evaluate that log. We also can't deal with if this had log base 3 of 4 plus 2, we can't add these together, because this, whatever the log is touching, is whatever is actually being operated on by that logarithm. It's sort of like having 2 times 4 to the third power. The only thing that the power is touching is the 4, and that 2 is just outside. So just want to kind of throw out that similarity to get us thinking about stuff. And what a log really means, and I think this is the most important thing, this whole thing says the exponent or power that we need to raise 2 to get x. So if we wanted to rewrite this previous example with the logs that we sort of undid it with, using this wording, we want to know what power we need to raise 2 to in order to get 5, right? That's what we want. So this as a logarithm actually looks like this. Log, well, 2 is the thing that we need to raise to a power, right? That's our base. And we want to get out 5. So this being able to rewrite and go back and forth between these is very, very important. And I like to just think of this as always remembering that our base stays our base. So if we have a base of 2 in our exponent, we have a base of 2 in our logarithm. And then they are opposites. So what was the power becomes the answer. What was the answer becomes the argument of our logarithm. So that's a little basic intro to logarithms. We'll talk more about them in some more videos.